Good morning, everyone. My name is Guna, and on behalf of TSDSI, I am very happy to welcome all of you to the third workshop in our micro workshop series regarding 3GPP standardization. We have a great lineup of speakers for this session today. So let me take the pleasure of introducing our anchor for the day, Mr. Nirant Amog, my good friend. He's a chief architect of standards at the Huawei India R&D Center in Bangalore. And he's responsible for the wireless networks research and standards work within the organization. And you could see that he's also very active with 3GPP. He's a rapporteur of 11 specs and technical reports in 3GPP related to vertical application services. So he's going to be the anchor for the day, and I'm going to let Nirant take over from here. Thank you. Nirant, please.
Thank you, Guna. Thank you, Guna, for the lovely introduction, and good morning to one and all. Firstly, I would like to thank DoT and TSDSI for hosting this lovely workshop, and it's my privilege to be the anchor of this workshop. And along with me is also the co-anchor is Dr. Samar Shailendra, who is also the co-chair for the TSDSI Roadmap Committee, and he works for Intel. And it's great. I mean, this particular workshop is about is the third workshop in the series of the DoT-TSDSI micro workshop on advancing 5G towards 6G, and this is dedicated to the topic of vertical applications and services. And at least I'm very sure that the last two workshops were immensely successful, and you would have all benefited with the topics that were shared related to mobile network services and technology and systems. And this particular workshop is pretty special because we know that 5G offers new services to new categories of vertical users. It's just not limited to mobile phones, but to all the vertical industries. And the capabilities of 5G are continuously evolving since the first release of 5G, and which is catering to very wide array of vertical industries, including public safety, railways, drones, industry 4.0, healthcare, utilities, you name it. And 3GPP and the global partners of 3GPP are all making efforts to make use of 5G in a very wide way. And hence this particular workshop is special, and it is focused on the 3GPP Release 19 studies on vertical applications and services. And as Guna mentioned, we have a great lineup of talks, and we will have the following agenda. So we have the introduction opening remarks by Kishore Babuji, who's the DDG of SRI at DoT Government of India, followed by the 3GPP overview and Release 19 timeline by Dr. Samar Shailendra. Then we get into the overview of Release 19 studies, where we have lined up 4 topics, which are hot topics of Release 19 in 3GPP. The UAS, or the drones phase 3 work, which will be introduced by Pallab Gupta. The ambient power enabled IoT, which will be introduced by myself. And the studies on future railways and smart station services, railway smart station services by Prakash R from CDOT. And again, hot topic of metaverse, which we have the privilege of having Eric, who steers this as well in 3GPP, followed by poll and Q&A, and the concluding remarks by our TSDSI Roadmap Committee co-chair, Samar. So with this as the lineup of agenda, so I would like to now provide a warm welcome to our chief guest, Shri Kishore Babu. So yeah, thanks for putting on the slide about Kishore Babuji. So Kishoreji is the DDG for Standards, R&D and Innovation at the Department of Telecommunications, and he firmly believes in the competencies of Indian innovation systems and entrepreneurial abilities of startups and SMEs. And he has always encouraged collaboration amongst the stakeholders. So he's well-known facilitator, and in his current role, he is facilitating engagements with the Indian digital communication technology companies in the domains of course, the standards, R&D and innovation. And apart from his valuable contributions in India, he is actively contributing to the ITU, International Telecommunication Union, which is the UN Special Agency for ICTs. So, I mean, the introduction, there is more to speak about Kishore Babuji, but given the limited time, I quickly want to hear to his words of wisdom and invite him to provide the opening remarks for this event. Kishore Babuji, the floor is yours. Thank you.
Yeah, thank you very much. Just to cross check, hope I am audible and clear to all of you.
Yeah.
Thank you.
Yes.
First and foremost, let me thank all the people who are present here, and also, distinguished members who are going to speak and share about, especially the use cases and applications in different verticals. From DoT, we warmly welcome all of you because this is a very important engagement. One extent is about developing technology. Second thing is about adopting and making use of it in the different socioeconomic verticals. As some of you mentioned that 5G is going beyond a kind of a individual mobile use or mobile application, and a lot of enterprises, lot of verticals are engaging, deeply adopting these technologies so that there are operational efficiencies and productivity and new streams of business, and of course, most importantly, creating life more qualitative and more better. Thanks very much for all the technology community for contributing and for the user agencies for adopting it. A few things I want to add, before the members further continue the engagement technologically. DoT has constituted interministerial committee for 5G use cases with more than 21 departments. You name the department which is having relevance, including education, health, industries, mining, water resources, sports, tourism. All these ministries are coming at one platform where, as a group, telecom service providers, technology companies, as well as research institutions, use case providers, system integrators. Together, we are approaching the vertical ministries and vertical departments to engage them proactively and handhold them in adopting these use cases. And we felt that there's a lot more we can do by India adopting these technologies at a faster pace, especially in 5G and of course 4G as well, and a lot more to contribute in the upcoming even release 19 preparatory process. And of course, there are other platforms like 1M, 2M, IEEE, IEC, where a good amount of qualitative work is going on with regard to the vertical applications and services. So DoT has been closely hand-holding as well as supporting all the stakeholders to come out with contributions for this release 19 preparatory process. And also through 6G Technology Innovation Group, we invite your contributions and support to chart out a roadmap for the 6G preparations, how India and industry and academia collaborative manner we can contribute for the engagement. And you're all the key partners in making this happen. Unlike in the case of 3G, 4G, I can see and government acknowledges a lot of competencies in the industry and global partnerships. This has to be more strengthened and engaged to convert them into for contributions which get cleared and approved on the standard platforms. And my invite to all of you, please participate actively for this preparatory process for release 19. And I understand that June there is going to be a presentation at 3GPP with regard to work items, and perhaps by September they will be finalizing. So it's an opportunity for all of us to streamline and finalize what could be kind of key contributions by end of February, by circulating and as well as engaging with all the TSDSI members as well as Indian industry, how together we can go to these standards platforms and make proposals which relevant for India as well as for the global applications perspective. And I also want to take this opportunity to invite you to visit to bharatdigicom.in portal, the portal which is, I have put it in the chat box, the hyperlink for this portal, where we want to we have created a kind of collaborative platform for user verticals as well as for the use cases and also for technologies to come together, collaborate and contribute, where details are available up to mobile number of the different technology companies as well as the experts. So kindly make use of this platform to build more collaboration, partnerships and successful engagement. With this, many thanks for inviting me for this important engagement, and I really want to thank once again all of you experts as well as TSDSI for actively taking this forward. Thank you very much.
Thank you, Kishore Babuji. Thank you so much for your inspiring words and your efforts on the mission for bridging the Indian innovations to global standards with diverse stakeholders collaborations. So this is very, very inspiring for us, and we would seek your guidance all the way through. Thank you so much for gracing this event. Now we would progress to the next part of the agenda, where I would like to introduce our next speaker, and my good friend is Dr. Samar Shailendra. He is the Senior Standards Architect at Intel and also the Lead Standards Delegate at India for 3GPP SA6, which is focused on application enablement and critical communication applications. He's also working as a visiting professor at IIIT Bangalore, and he is the co-chair of TSDSI Roadmap Committee and also vice chair of TSDSI Study Group Networks. So he has extensive experience in research in networking domain and is very passionate about standards. So please join me in inviting Samar to provide us with an overview of 3GPP and insights into the Release 19 timeline. Samar, the floor is yours.
Yeah, thank you, Renan. Thanks for that very passionate introduction. In fact, I'm feeling more proud about myself after your introduction. Thank you very much. Thank you, Kishorji. This event has been possible only with his collaboration and inputs and the support from Kishore Babuji and DoT. The extensive idea of executing this workshop, the confidence to make it happen, and the support which has been provided is phenomenal. The introduction to 3GPP has been something which I have been doing in all the 3 workshops, because this is very important for, especially for the members who are attending it first time, because all the 3 micro workshops were focused on different aspects of studies in 3GPP Release 19. We all know 3GPP by now very well. We all know that 3GPP is consisting of the organizational partners, and TSDSI is one of the OPs among all other 7 OPs, 6 OPs which are there from China, Europe, Japan, Korea, and United States. All the companies who wants to contribute to 3GPP, they have to be the individual member through TSDSI, and TSDSI being the organizational partner provide the opportunity to become the IM there. That's the way how you participate and contribute in 3GPP. The other constituting body of 3GPP is all the MRPs like COAI in India and others who provides the requirement to 3GPP. And there are many other external bodies and organizations which can also come to 3GPP and participate through license and other formal framework which 3GPP has established. Next slide, please. I quickly mentioned that there are 7 OPs from Array, BATIS, CCSA, HC, TSDSI, TTA, and TTC, where TTC and Array both are from Japan, while others are from Korea, US, China, Europe, and of course India. Next, please. A good motivation to participate in 3GPP, because this is the organization as far as telecom standards and telecom execution in the world is concerned. Has got 23+ years experience with 10K active technical specifications across all releases, more than 100,000 technical contributions happening in 3GPP. 750+ companies are involved, and 2,000+ man years in cumulative meeting time has been invested into it. And there are 16 technical working groups, which I'll be very briefly talking about in the next slides. Next, please. Quickly about the IAMS, as I mentioned, IAMS is the vehicle to contribute to 3GPP. You have to be a individual member through TSDSI to participate there, which provides you an opportunity to participate in the technical specification groups, to consume the results and the specifications generated by 3GPP. And of course, you have a lot of say in the entire 3GPP standardization process by becoming the individual member there. Next, please. So this is the important aspect in my opinion. As 3GPP name says, it's a partnership project, which is headed by the Project Coordination Group, PCG. Then it has been divided into 3 verticals of technology. The first one is the RAN, Radio Access Network, which is further divided into 6 working groups where the actual technical work happens related to the telecom network. The second is the rightmost, which is TSDSA, the system services and systems aspect, where the core network aspects are being discussed. Again, this is divided into 6 working groups which are focused on different aspects related to the services SA1, which is the topic of discussion for these micro workshops, because that's where the requirements get generated for all others to consume, followed by the architecture, security, codec, media, telecom management, and the applications. Then finally, you have the core network and terminal, which is the third group, the CT group, which is focused on the protocol defining aspects and the normative work, or the stage 3 work, which we call in 3GPP, which defines the different type of protocols, the specifications which can be consumed and implemented by the mobile network operators or anyone who wants to consume 3GPP specifications. Next, please. So briefly, these are the different stages which any specification process goes through in 3GPP. So similar process is also followed in TSDSI, because that's a typical life cycle of any SDO. You have the requirement stage, which is done by the SA1, which we are talking through this micro workshop, because that's the place where the foundation for any specification is being laid. Unless you have the requirements in place, you cannot really define the technology for it, because the technology gets defined based upon the requirements and the use cases which has been agreed upon in the group SA1 or in the 3GPP. Followed by the stage 2, where the architectures and the protocol architectures, etc., the protocol aspects being defined, the security, applications, etc. Followed by the stage 3, where the actual protocols for all those architectures are being discussed and debated and defined. And followed by the stage 4, where you have all this marketization, conformance, testing, and usage of the adopted specifications is being done. The trials, the tests, etc., is being taken care of. Next slide, please. This is how TSDSI is trying to align itself with the release 19 and release 20 work. We all realize that you have to start early, you have to create an ecosystem to be effective and contributing to 3GPP. TSDSI is relatively a new body as far as the entire 3GPP ecosystem is concerned, and the other standard bodies are there, SDOs are there. So if you look at this, you have the release 19 time frame, where is the ongoing work. Recently the entire release 19 has been shifted by a quarter. That means that the workshop which 3GPP was planning to hold has been moved to the June time frame. I see this is an opportunity in itself, because this gives us a little more time to be contributing to the 3GPP requirements work. The other workshop which will be taken up, or the packaging which we call, has also been moved to the September. So packaging is the time when actually the 3GPP companies together decides that what is going to be the scope of the release 19. So that will happen in September. The ongoing SA1 work, which we have been presenting in the last two workshops, and this workshop will be talking about the remaining work on the stage 1, that will be finalized in September time frame. That is the the normative work is supposed to be completed by September time frame, and the 100% completion of that is targeted in November time frame. That means now we have slightly more time to become further having a presence in the entire release 19 ecosystem. So I see that as a great opportunity, and I encourage everyone to contribute significantly to the requirements of the release 19, because once you have the requirements being positioned in release 19, we have the opportunity and we have the collaboration with all the other members and contributing bodies to bring the technology to satisfy those requirements. To facilitate it further, we will be organizing certain trip forums, which I'll be talking about towards the end of the session. The TSDSI has organized these micro workshops 1, 2, and 3. Then we have the strip forum, which will be discussing all these requirements and will be contributing back to the 3GPP. And these are the study groups where the actual technical works happen. So if you really want to know more about this, I would really encourage to get back in touch with the TSDSI Secretariat. They can provide a lot of extra information and learning with respect to this process. Next slide, please. So the next steps related to the participation and contribution, as I just mentioned, please reach out to Mr. Bishnoi, fill out the expression of interest form. So the expression of interest form will be provided at the end of the workshop. Please fill that up. Based upon your interest, your inclination, and your requirements, TSDSI Secretariat will reach out to you. They have been very instrumental in mobilizing the Indian ecosystem to contribute and participate into standards. They have the expertise in terms of the visibility into 3GPP system, into the ITU systems, and a lot of other standard bodies. If you really want to contribute to 3GPP, we strongly encourage you to do that, because 3GPP is a fantastic platform to learn, collaborate, and contribute. So be the TSDSI member and join 3GPP as an IM. You have to follow certain process which 3GPP has laid down. All these are available on this working process of 3GPP. It's a link in itself. So you can, if once the slides are available to you, you can click on this, or you can even search on Google. It will provide you all of that. You can choose a topic of your interest where you want to contribute. You have to subscribe to the email list which are available, and the working procedure again lays down the process to do that. Towards the end, I would say that once all these talks are completed, you will have a poll question. Please do answer those poll questions, because that will provide us a lot of insights and visibility in the kind of interests you have, and we can tailor-made our offerings, our solutions, and our efforts to make it happen. You will be mailed up with an expression of interest form. The link will also be posted in the chat here. Please do fill that out form, because that will provide us more details about your organizational structure and the possible interest which you may have in it. And finally, if you have further queries or you need some more information, we have General Bishnoi, who is very instrumental in providing all the details and support with respect to the contributions to 3GPP and how you can become more valuable and contributing to the 3GPP ecosystem. So with that, thank you very much. I'll hand it over back to Nirant, and these are some of the important links which you can refer to. So thank you very much, and thanks for this opportunity, Nirant.
Thanks, Amar. Thanks for the quick overview of 3GPP, and also a lot of information that you have shared on how the audience can connect with TSDSI and also engage in this process and know more. It's never enough. I mean, it always feels it is never enough. But looking into the pace of which we are running this workshop, I am sure that many people interested will get in touch with TSDSI. So thank you, Samar, for providing your insights onto it. And now we enter into the main session of this workshop, which will basically provide the overview of release 19 studies in 3GPP. And as you've seen during the agenda, we have a very impressive list of speakers. And our first speaker is Mr. Pallab Gupta. Can you please, thank you, Akash, for displaying Pallab's profile. So Pallab is working as a senior standardization specialist in Nokia. He has a huge working experience of 18 years in mobile core network domain. And his research activities, of course, involves working on drones, or how we know in industry as uncrewed aerial systems, and is contributing it into various works in GSMA, including the GSMA ACJA, which is the aerial connectivity and joint activity with the Global UTM Association. And at 3GPP, of course, these all activities of GSMA ACJA all culminate into 3GPP. And at 3GPP, he is part of the company's SA2 delegation and has been contributing to the UAS work in 3GPP SA2 from release 17 onwards. So it's a privilege to have Pallab speak on this topic, and please join me in inviting Pallab to provide us with the overview of the phase 3 study of UAS at 3GPP SA1. Over to you, Pallab.
Thank you, Nirant, for the kind introduction. I also thank DoT-TSDSI and DoT for inviting me as a panelist in this workshop. And as Niranth has mentioned, I'm going to talk about the uncrewed aerial system, which is synonymous to drones. So 3GPP has already worked for past 2 releases, release 17 and 18, on various aspects of system architecture and application level in enhancements that are needed to support drones. And now at 3GPP SA1, they have also started discussing phase 3 of US study, where they're discussing different use cases and related system requirements. So throughout the next 15 minutes or so, what we are going to look at is some background and motivation about why 3GPP has started working on or looking at aspects of supporting US through the 3GPP system. We will look at very briefly what has been already done in release 17 and what is currently being done in release 18. And then we will go into the release 19 timelines and look at some of the use cases and potential system requirements that are being discussed in SA1, 3GPP SA1 for release 19. Okay, could you please go to the next slide? So on the background and motivation, I think we all are aware that in past few years or so, there has been variety of different commercial US types that have come up, different types of services and scenarios that are rapidly emerging. And to support this, and also to support use cases like beyond visual line of sight radio communications, etc., we need a large scale and cost efficient UAV enabled services. And if we look at the 3GPP system, I mean, the 3GPP system already has a very proven identification services. It can provide network-based redundant geodata. It can provide SLA-based critical communication support. And if you look at 5G, we have then additional these dedicated 5G slices, and then we have cloud and edge computing capabilities. And it can also provide a very high level of reliability in terms of communication. So 3GPP system has been considered as a very key enabler for such a large scale adoption of UAVs or different use cases related to UAVs. And also considering the fact that now the 4G and 5G cellular networks are widely deployed across the world, it provides a standardized and secured way of introducing the services. And that was the main motivation for looking at what are the system enhancements we need to support the drones in the network. And the work was mainly concentrated with objectives like how to enable beyond vision line of sight operations of UAVs, for which we need reliable communication between the UAV and the controller, and also possibly the other players like the USS, UTM, etc. We also need to look at how we can provide coexistence of ground-based UAVs, which is generally the 3GPP network or the mobile network is designed to support the ground-based UAVs. And now we have these aerial UAVs, because the UAVs, if they are using the 3GPP UAVs, so they will be moving at a height. So how we can provide a similar type of experience, or more or less same type of experience to both ground-based UAVs and aerial UAVs. So that's also one aspect that the 3GPP kept as part of the objectives. And then the third one is, of course, how to enable a regulated UAV airspace which is safer for operation. So with these three objectives, in release 17 and release 18, we have worked on various system aspects and improvements to existing features to support UAVs. So if you could go to the next slide, please. So in release 17, if I have to summarize very briefly what we have done, so there were two separate working groups in the stage 2. We're working on different study items related to US. The 3GPP system architecture group, the work group 2, worked on aspects like identification and tracking of the UAVs. It also provided a new mechanism where which can be used to provide authentication and authorization of UAVs. So basically, the 3GPP system has provided an interface towards the USS and UTM, an SBI-based interface using which a UV can be authenticated and authorized to be used with a UAV. And then this also provided additional mechanisms of authorizing flight path and also authorizing communication between UAV and UAV controller. So those are the aspects that were introduced in release 17 as part of the system architecture enhancement, and as part of the application enablers in the 3GPP SS6 group also worked on aspects like how to use the seal architecture for some of the use cases in the UAV, how to enable broadcast communication between the UAVs, then whether the 3GPP could add some additional capabilities to provide uh, additional information, for example, to verify the reported location of the UAV, etc., and also QoS provisioning for the C2 communication. So those are the aspects that were then introduced in release 17. If you could go to the next slide, please. And in release 17, which is currently ongoing, we have three different, at least 4 different working groups in 3GPP who are working on various aspects of supporting the UAV. So we have again the Asset 2 working group, which is building the features on top of release 17 features that were introduced, and in release 18 the features that we are working on are basically how to support direct UAV to UAV controller communication using PC5 interface. That is one feature that is being introduced. Then there are 2 other aspects that right now in release 18 we are working on, and these are basically how to support the broadcast of remote identification. So there are various regional requirements related to flying a drone in an area, and then the requirements are basically that the drone has to broadcast certain information when it is flying, which the broadcast could be received by any receiver or any interested receiver on the ground, and with that broadcast information they should be able to find out information about the drone, its owner, and possibly the flight path that it is going to take, and so forth and so on. So right now, if you see this broadcast of remote identification, the regulations say that it uses things like Bluetooth and Wi-Fi, which are widely adopted. In release 18, we are also trying to then introduce how we can possibly use some of the 3GPP features. For example, the PC5 based interface could be used for broadcast, right? So we are introducing a mechanism where PC5 based interface can be used for broadcasting or remote identification. And also, we are looking at the broadcast multicast broadcast system that we have, the 5 MBS, how we can use that for supporting the broadcast related requirements for flying the drones in an area. And also similar to that, DAA, the detect and avoid related aspects are also being looked at, how we can support transporting the DAA messages through the 3GPP system. So those are the aspects that are being then introduced in release 18 as part of the system architecture. And again, a similar parallel study is also going on in the SS6 work group, where the things that are being looked at are, for example, how to support multi-USS deployment, or if a UAV supports both UU and PC5 based direct communication with the controller, then how we can make some coordination between these two to provide more reliable connectivity between the UAV and the UAV controller. And then they're also working, SS6 is also working on some aspects of the detect and avoid related services and applications. And in release 18, we have also the 3GPP RAN working group bringing up some features. So in 3GPP release 15 of LTE, there were some features introduced to support UAVs. So similar features are now being introduced for new radio, the 5G new radio, also in release 18. And these features are basically some UV triggered measurement of measurement report based on some configuration like the height threshold. So if the UV goes beyond a certain height, or if it comes below a certain height, then it will report it to the GNODE base. Reporting of height, location, and speed measurements. Then the flight path reporting. So in terms of some 3D waypoints and the time, the UE would report its flight path to the GNODE B, and measurement reporting based on configured number of cells, etc. So these features, which are already available in LTE, now have been now in release 18 are being introduced in the new radio also. So these are the features that are currently ongoing in release 18. Now with this background, let's then move to the next slide, where we look at the release 19 timeline and some of the use cases and potential system requirements that are being discussed. First, so for the release 19 timeline, a feasibility study for a phase 3 of last year, requirements are being discussed to support some new regulatory requirements and application specific requirements to support the UAVs in the network. And as Samar had mentioned, the stage 1 freeze has now been moved by about a quarter. So right now, the completion of the stage 1 system requirements gathering work has been targeted for Q3 of this year, 2023. So we have a good opportunity if we want to push some new requirements related to some specific use cases that we see here in India or in this region. This is probably a right time then to go and push those requirements in the 3GPP SA1, so that those can be then consecutively taken by the stage 2 for study and then brought into this specification. Okay, next slide, please. Okay, now in next few slides, we'll see, I have basically tried to put the new use cases that are being discussed into some themes. So one of the aspects that in release 19 SA1 that we have been discussing is related to network assisted detect and avoid. So in release 18, as I mentioned, we have done some improvements, so we have done some features to support DA, but that's mainly related to transporting the detect and avoid messages between the UAVs or between the UAV and the USS UTM. So it's basically providing a transport layer through the 3GPP to transport these messages. But what in release 19, what we are looking at, or the use cases that are being discussed, is whether the 3GPP could provide any additional information to, for example, the UAV or the USS UTM to support the detect and avoid kind of use cases. And that could be, for example, providing the location information or tracking information, or maybe using, for example, some sensing data from the 3GPP network, if it could provide some useful information to the USS UTM to support the detect and avoid kind of use cases, to provide a safe airspace for the usage of drones, right? So that's one area that is being heavily discussed in the SA1 for system requirements. Then the second thing that is being discussed is about UAV detection. So if you see, until release 17 or release 18, what we have done is we have introduced features for identification of UVs that are being used with UAVs, right? So we can identify when a UAV is used with a UAV, but then there is no a certain mechanism available in 3GPP to detect when the UAV is airborne. Okay, when the UAV is flying, there is no way to detect that it is the UAV is actually flying or not. So that's one area which is being discussed in SA1, how to detect and then we have to also see that detecting the UAVs also then opens up multiple other use cases. For example, detecting of UAVs could be then related to some security and safety related use cases, for example, intrusion detection, or for example, if UAVs are not allowed to go around certain zone or certain areas, then this detection of UAVs by the network could help in those kind of enforcement also. So these kind of use cases then opens up with the ability to detect airborne UV in the network, right? And then there are also a few other regulatory requirements coming up related to detection of aerial UVs. And okay, it's not just so basically one example I can give of is in Korea, for example, they are looking at urban air mobility. They're going to do some trials, and there is a very there is a plan to go live with the urban air mobility system by 2025, and the expectation is that at that time it is possible that the UVs that are on board in in an UAM, those UVs may not always support this kind of reporting of height-based reporting or whatever we have seen in release 18, right? So there is a regulatory requirement that even if there is a normal UV which is on board a UAM, the 3GPP network should be it should be possible for them to detect such kind of UVs and then report it to maybe the USS or UTM. So there is this kind of detection, UAV detection requirements also coming from, say, different regulations in different regions. So these are various aspects related to UAV detection that is being then discussed in SA1, and accordingly some system requirements will be finalized by probably by Q3 of this year. Then coming to geofencing. Now okay, this is more related to visual line of sight operation of UAVs. So in visual line of sight operations, you have always this restriction that the UAV cannot go beyond, say, 120 meters from the controller. Now there is obviously there is a way you can control it at the OEM level itself, but there are also discussions going on whether the 3GPP system can support in ensuring that the drones are adhering to this kind of requirements, right? So if the UAV is using 3GPP UV, if it is using 3GPP connectivity, then it's easier for it to find out the location or do the tracking. And if the 3GPP system also knows, for example, the location of the ground station controller, or if the ground station controller is also using a UV, then 3GPP system should be also somehow able to then determine the position of these two UVs, or and then find out some relative distance and provide information to the USS UTM if it sees that it's going beyond the limited range or whatever. So this kind of geofencing requirement is also being discussed, and then potential system requirements could be then agreed in next few meetings around this area. If you could go to the next slide.
Yeah, thanks, Pallab. Pallab, can you please wrap this in 2 minutes, please? Thank you.
Okay, so yeah, maybe I'll not take more than 2-3 minutes. Then obviously we need to look at the safety and security aspects, and we need to also see how we can improve the C2 reliability. So around those aspects also we have various discussions going on new use cases and requirements. And obviously the traffic management part, if we could support with some additional information from the 3GPP system towards the USS UTM to support the air traffic management that is done by the UTM, right? So there are different use cases and requirements being discussed around these aspects. If you could quickly go to the next slide, just to elaborate on some of the use cases. For example, one of the use case could be in case of pre-flight preparation, how the 3GPP system could support. So here the assumption is that the UAV is using 3GPP UV for connectivity, and one of the use case could be that when the UTM is, or the USS or UTM is trying to authorize a flight path to a UAV, it can basically provide the flight path information to the 3GPP system, asking for information like what kind of QoS the 3GPP could provide, or some predictions and statistics related to the quality of experience that the UV can get around the flight path. And based on the report from the 3GPP, the USS could then decide which would be the best flight path that the UAV could take in order to ensure that it has the proper and reliable connectivity throughout its path. And it's not just at the pre-flight preparation, it could be used during the flight of the UAV also, the USS UTM could probably request the 5G network to continuously monitor a particular flight path that the UAV is taking, and if it sees any if it predicts some issues on the flight path, it could then report to the USS UTM, and then USS UTM could probably then instruct the UAV to or the controller, the ground station controller, to change its flight path to an alternate path where it may get better connectivity. So these are some of the use cases that are being discussed, and if you could go to the next slide, and that would be probably the last one on this aspect. So on the network assisted DAA that I was talking about, so this is one of the examples I have taken from the SA1 TR that is being discussed. So let's say that there are two UAVs, UAV A and B, which are using 3GPP connectivity, and then there is a UAV C which is not using any 3GPP connectivity, but the 3GPP network, for example, has some sensing capabilities to identify that this is a UAV, and it can also do some tracking of these. So the 3GPP system can then provide the information about the location and the tracking of these UAVs to the USS UTM, which can then which can be used as an assistance by the UTM to avoid any kind of collisions, etc. So yeah, so these are different use cases that are being discussed. And can you go to the next slide quickly? Some of the potential system requirements that are okay, these are not yet completely agreed. As I said, the study is going to complete by Q3 of this year, but these are some of the potential requirements, that system requirements, that are being then identified based on all these use cases. So one of them is detect and report when the UAV is airborne, then monitor and predict network conditions along the UAV flight path and report to UTM, collect and provide information to UTM related to UAV detection, collision avoidance, etc., and to support the visual line of sight related regulatory requirements, for example, the maximum distance between the controller, ground station controller, and the UAV. So this study is still I would say not quite matured, and we have enough scope to push new requirements. There will be further meetings in February and then in April and May for SA1. So I think this is a very nice opportunity. If we have some use cases and requirements from our region in the India specific requirements, we could possibly then push them. This is the right time to push those requirements into the 3GPP through 3GPP SA1 work. Okay, one more slide, 30 seconds more, and then we can hand over to you. Yeah, and then in this last slide, I just give you some pointers to different other fora that are working on UAVs, and the most important from this is the GSMA aerial connectivity and joint activity, because this is a joint collaboration between the GSMA and the GATMA, which is Global UTM Association, and here we have participants from the 3GPP or the mobile communication world and from the aviation industry, and this forum basically works as a platform for collaboration between the aviation and the cellular ecosystem, and it's basically acting as a platform where we can get the requirements from 3GPP from the aviation industry and then bring it to the 3GPP. So this is also this is the most important, at least in terms of 3GPP. But then there are various other fora which are working on different standardization aspects and also different regulatory aspects. And this is not an exhaustive list. This is just to give you some pointers about the other fora that are working on US. So with that, I would like to then thank and give it back to you, Nirant.
Thank you so much, Pallab. Thank you for the great insights you provided on the 3GPP work on UAS, and it's overwhelming to see how capabilities both at the UE, the network, and the applications are all being utilized by have been being contributed by various forums, and I'm sure India will also play its part within it, and it's bring requirements to 3GPP. Thank you, Pallab. So quickly going on to the next, so we are on time, we're a little bit lagging on time, so I will try to make it up. The next topic is a study on ambient powered enabled IoT, and I will be presenting this particular topic. So quickly on the next slide, please. Thank you, Akash. The topics that I want to cover is status of IoT related capabilities in 3GPP, And of course, everybody wants to understand what is ambient powered enabled IoT, and how use cases and potential requirements are developed, and what is the type of future work we are seeing in 3GPP on this particular topic. Next slide, please. So, I mean, we've been talking about the IoT technology since a long time, and basically there are always driving forces. So it's always overwhelming, right? You see IoT in every generation of technology we speak about, and still it is not enough, right? So we always talked about 1 billion devices connectivity, and all over wireless, everything over wireless. So when people are going into wireless with various and keeping verticals into mind, so the vision is to scale to at least 100 billion devices, IoT connections by 2030, which basically would mean like internet of everything, and in every vertical and in every sector. And there are technology enhancements that will continuously keep evolving with respect to uplink, transmission reliability, latency, and also the price point of the device and the module, and the positioning technologies themselves, and the capabilities of how with reduced capabilities things can still work with the common technology of 3GPP. So these are the driving forces. Can we go to the next slide, please? So in the next set of slides, I'm going to quickly introduce about the existing state of 3GPP systems with respect to IoT related capabilities. I think the effort started way back release 13 more formally, but there were also cases of using 3GPP systems for IoT even with release 8 versions. But more specifically, I think in release 13, three work significantly happened in 3GPP, which is LTE-M, NB-IoT, and EC-GSM IoT. So we all know that IoT devices need to support long battery life and also low cost. And also the three different technologies also provide different type of coverages and also the bit rates that they support for the devices. And they also have different type of deployment views. One is how to reuse existing LTE deployments, and the others where the entire solutions of IoT and can be operated like any other MNO does with standalone NB-IoT deployments, and also leveraging the GSM and the edge technologies to also deliver the IoT services. So of course there are a lot of upgrades done in future releases to all of these technologies, and they're continually evolving, but they all have their space. So the whole idea about this IoT space is that even though we have multiple technologies and multiple technical work within 3GPP, they all have a space with respect to the solutions and the verticals that they cater to. Can you go to the next slide, please? And this was in the 4G era, and now in 5G era, of course, we all know that two new dimensions came up. One is massive connectivity, and the other one was the low latency and the ultra reliable requirements. So due to Industry 4.0 requirements, so which many forums and basically the requirements came from different regions, and we could see that the use cases like motion control, use of robots, mobile robots. So the innovation in the industry automation or the factory automation was taking place, where they were migrating their viewpoints from more like a wired system to a complete wireless systems, where looking at the arms of the robots or the automated guided vehicles, everybody working in sync to achieve the industrial IoT use cases. So all these use cases like process automation, mobile control panels, they've all been developing requirements for the 3GPP system in the necessity from a point of availability, the application requirements of cycle time, the type of payload that is expected of these use cases, and the type of number of devices and the density that can be supported, and the area at which they operate. So all these are the KPI requirements that were supported by the release 16 version of 5G NR for industrial IoT. And going to the next slide, please. Further in release 17, so it was also felt that more scenarios need to be addressed, because the innovations kept happening in IoT space, right? So as we were looking more into connecting fridges and other things onto the network, it was more now into also industrial applications where smart wearables, industrial wireless sensors, and video surveillance use cases had to be addressed. And for this, 3GPP worked on what is called as 5G reduced capabilities, or also popularly known as NR lightweight or NR light, which worked in release 17. So again, the major focus was on low cost modules, especially operating at 20 megahertz, and also with very few number of antennas, receiving antennas, that is 1R or 2R to the max, and then also supporting coexistence with eMBB devices. So the same RAN could also be utilized for high bandwidth as well as low bandwidth services, and many more functionalities, including low latency slicing, how to offer slicing for red cap, as well as positioning and low power consumption. So as you see, there are at least 5 that we all know that 3GPP has worked on. And now we are going to the next slide. We enter into more newer use cases, what we call as ambient power enabled IoT. So everybody comes to understand what ambient IoT device would really mean. So we know any device would have basically a requirement for energy, and then most of the IoT use cases, we knew that the energy harvesting mechanisms were either battery based, or at least long life batteries, or even always connected. I mean, always energy was always connected to the provided to the devices. So now I think 3GPP is working on newer devices where the energy harvesting would either be batteryless or with very limited energy storage capabilities, like using a capacitor. So a typical architecture of, or parts of an ambient IoT device would look like this. So where the harvesting functionality would be basically coming in from, we all know these type of examples, right? The tags and sensors, what do you call, solar sensors, and so on. So energy harvesting happens from radio waves, solar energy, thermal energy, and even mechanical vibrations. And of course, there would be some type of a power management requirement at the device, and also how to manage certain, at least limited energy storage. And of course, typically it should also do the real application function about the sensing, and also there would be requirement for processing both the application as well as the connectivity part. And there would also be chips, there would also be modules for radio. So the definition of this type of device is now being and the network to support this type of devices are now being investigated in 3GPP, and the technical report in 22 to 840 is being developed, and which is studying on the ambient power enabled Internet of Things. So I'm going to give you snippets of the use cases and requirements coming from this particular TR in the further slides. Next slide, please. So I'm already SA1 has already defined 30 plus use cases, and I'm going to go through a couple of use cases. So here, one of the use cases is the ambient IoT and automated warehousing. So a typical thing is verification and unloading from transport, and then getting it into the inventory, and managing it within the inventory, and also taking it out and loading it into the next destination, right? So this is a typical case for an automated warehouse. And here, the most prominent ambient IoT devices that are thought of are tags, which are attached to necessary areas such as the goods themselves and the shelves and all the relevant communication equipment. So these type of use cases have already been discussed in SA1, and they've come up with some potential requirements. So if you see the potential requirement, the obvious one is that the type of devices are almost batteryless or with very limited energy storage. So 3GPP system should be able to support communication with these type of devices. So we're talking about a network which will be able to latch on, allow these devices to latch on, communicate, and also perform their application interactions. And the second aspect we see is more about in terms of how to provide the information from these devices to third parties, because the consumers of these goods and others, we see that we are already in the online shopping era and so on, and there are a lot of B2B and B2C activities happening around, and the information coming in from these ambient IoT devices like tags are also relevant and more important for the third parties as well, who would like to receive information from these warehouses as to where their goods are and what's the status. And while they are doing these type of communications, there needs to be adequate security mechanisms and also authentication and authorization mechanisms in place. And because now we are talking about billions, and at least in warehouses we would have, they're dealing with millions of goods, and so there should be a provision of handling these ambient IoT devices in bulk. Next slide, please. One more relevant case from India perspective is smart agriculture. So the case here is that the devices, the ambient power-enabled IoT devices, can be used in smart agriculture to monitor things like air temperature, humidity, carbon dioxide concentration, the light, the soil temperature, humidity, and pH. And one of the interesting topologies that has also been thought about is that maybe the device directly connects to the network, but here it is also possible that there could be a picocell or a reader UE which has MNO subscription, which is placed in these greenhouses, which can communicate with the ambient devices, ambient IoT devices, and provide information to third parties and to the network, and hence to the third party. So again, the requirements here are can be seen. Communication with third-party application server and also the security aspects. So typically when 3GPP develops a use case, it has got the following structure. There is a description, there are preconditions, there are service flows, the post condition, and also comments or descriptions about existing features which are partially covered or fully covered already for the use case, and also the new requirements. So the potential requirement that you have seen listed here are part of the last part of the discussions within the use case in SA1. There are also other discussions with respect to the KPI that we saw for the industrial IoT case. So going to the next slide, I'm going to quickly introduce you to one of them, and I'll allow the next ones to be viewed offline. Next slide, please. Yeah, so for ambient IoT, what's interesting is in the topmost row. So you see there are use cases. So there are, as I said, there are 30 plus use cases, and a lot of their service KPI requirements for these use cases are being developed. So we have the maximum end-to-end latency is one of the parameters that have been discussed. So each use case, there is investigation about what is the required support for it, the service availability support for it. Let's say in smart home, the service availability support is 99.9%. The reliability is also being discussed, with what reliability the entire system should work with, and what is the user experience data rate. So this is more by investigating the application flows and how the messages are triggered at what frequency, and how the what type of data rate should the system support, the size of the messages, the density of the devices. Some of them are categorized as indoor, some of them are use cases are categorized as outdoor, some are in mixed fashion. So the coverage of the application itself can range to several kilometers to even meters within the home. So the device density, again, we could see hundreds and thousands of devices per kilometer square, or even in terms of automatic intra-logistics in automobile manufacturing, the device density is shown as 1.5 million devices per kilometer square. And there are, again, communication ranges, what type of communication range we expect to help connect with these ambient IoT devices. Then the service area dimensions, to what area should we cater to? Should it be a very small area to a very, very large area, indoor, outdoor? And the mobility of the device itself, at what rates the device transfers information. And more interestingly now, because we are talking about IoT, the positioning technology or the location aspects are very, very important. So there are further KPIs for positioning technologies, like the positioning service latency, the availability of the positioning service, and the accuracy of the positioning. So we are going into very, very small locations, accuracy of the locations, to even large. So everything has to be supported. So the next two slides give you a summary of more use cases and their service KPI requirements. I would like to kind of skip them quickly. Go skip the next two slides, please. Yeah, skip this slide. Yeah, this is the slide that I want to talk about in future. So you know now that how 3GPP works on use cases and requirements, and what type of technical requirements they develop, which they envision that the 3GPP system would cater to. Now, in SA1, the current work that we are now looking at, all the use cases and work that is 65% complete. and it is envisioned that the target is that by March 2023 they would complete the study, and they'll start doing the normative work for release 19 upon that. And simultaneously, there's also work in RAN, which is again targeted to be completed by RAN 100, I think by September, not September, maybe by June. And basically, this is targeting to already studying a new 3GPP IoT technology suitable for the deployment in a 3GPP system with all the ultra low complexity devices and ultra low power consumptions. And also, this particular study will target that this particular segment will fit in below the existing IoT technologies like NB-IoT, LTE-M, and RedCap, and it will not be aiming to replace these. So currently there is a TR that has just started, that is 38848 in RAN, and they are already looking into categorization of the use cases and how to represent these use cases in a more general way, so that they can have future proofing of the use cases that are developed in 22840 of SA1. And they're also going to work more closely on the at least discuss and the design targets for the RAN, like power consumption, complexity coverage, data rate, positioning accuracy, and do a comparative assessment and then conclude with some recommendations for how to support ambient power enabled IoT. So going to the next slide quickly. Yeah, so the summary is that looking into all the study that I've just briefly introduced to you, the use cases, requirements, and the RAN technology all seem very relevant to Indian vertical industry scenarios as well. So there is a huge opportunity to contribute to the ongoing work, and I am hoping that if there are questions, we engage on these topics and work offline in the aegis of TSDSI to see that the type of requirements and use cases that can be further taken into 3GPP and the work developed to suit Indian deployments. Thank you so much. So that ends my presentation. And of course, everybody are invited to please provide your viewpoints and questions on the chat, and we will come to that as soon as we are able to do the polls. So without quickly wasting time, let me invite our next speaker. So our next speaker is Mr. Prakash. He is a technical expert in Center for Development of Telematics, CDOT, as we all know. He has been working as a researcher in telecom industry for the past 29 years. So he's a well-known expert in India in wireless systems, and his interests are also aligned with his research on software-intensive telecom systems, future wireless networks, data networks, cloud computing, software-defined networks, open source, and standardization. He also is a distinguished member of IEEE senior member, IET fellow, and ACM member. And he also serves as chair in the study group networks of TSDSI, which is the main study group where 6G study is happening currently, and he's the chairperson for that study group. As we all know him, most of you might already know him with he is represented in many technical conferences, forums, and standardization bodies. He's a well-known industry expert and has a great passion for innovations and bridging them to standards. So please join me in inviting Prakash to provide us with the overview of 3GPP work and studies related to future railway systems and railway smart station services. Over to you, Prakash.
Thank you, Niran. Thanks for the seminar. Thanks to DoT and TSDSI for the opportunity. Am I audible? Hello?
Yes, you're audible. Yes, you are audible.
Okay, thank you. So today's topic is on FRMCS Phase 5 and the smart railway station. So instead of directly getting into FRMCS, I will spend a few minutes on the background, because we probably have a mixed crowd here, and also FRMCS is not something that we deal on a day-to-day basis on the telecom. So just to get the perspective here, we anyway know that we've been doing generations, and we are now using 4G extensively. 5G is getting launched, already launched in quite a few places. India, it's getting launched from the past few months. And parallelly in standards body, work is started on IMT 2030, which is 6G. Academia, institutes, and companies have started research on that. So if we see 5G is in trials, advanced. Maybe businesses are trying to figure out how to use it, so on. But then if we try to, that is at 4G, 5G, 6G of brand names. If we try to dig into standards, what does it mean? How do these map it the releases? LTE 4G started. We had 3G before that, so I'll not get into that. We call it release 99, and we got it merged into this. But somewhere around release 8 is where we got the LTE, which is a 4G, which was quite a bit dramatic change from the previous 3G. It went into all IP network, and that is where the 20 megahertz and other things came in. And from there we started going to release 9 and 10, and 10 is what LTE advanced, which is between 8 and 10 is most of the 4G networks currently. And you sort of get quite a bit of benefit by the time you reach that. Beyond that, it is incremental and depending on the operator. If the operator has a need for a specific feature, we get it. But then it was between 8 to 10, it is LTE, 8 and 9 is LTE, then we went into LTE Advanced, then we went into Advanced Pro. And if we look at the diagram here on the right bottom, this is a diagram which I wanted to show, because when we usually see a list of features, it is not obvious to us what is happening in the release. Okay. So we start with some basic feature set, which became the release 8 and 9. We got the basic data, voice and broadcast in. And then we started adding things like carrier aggregation, higher carrier aggregation, then 256 QAM and so on. The dark blue hexagons that you see. And as we move forward into the release 13, 14, you start seeing break into features, bundling of features, what goes into mission type communications, what goes into could later lead into 5G broadband, enhanced broadband, mobile broadband, and then device to device and so on. But then this is an aspect that I would try to highlight here. That is, there is a basic stream of communication that is going in. And then slowly the applications, the various types of applications have started coming into the 3GPP aspects. And from communication only, a lot of what you call needs of the end user started getting into the system. Okay, can we go to the next slide, please? So I'll pick up one of the critical ones, which is what we call the MCX, which is the mission critical features. And mission critical services were existing even before we had LTE or we had got into this. It's a parallel activity which was happening, and mission critical sort of got built over the 3GPP frame. The needs of the segment was introduced, and if like already the earlier speakers have talked details about how the 3GPP operates, but then you see, to get a mission critical service in, you get the service aspects in SA1. If there's anything on the architecture, get it SA2, then the security and so on. And even though SA6 is the one that was brought in specifically for critical communications and mission critical communications, the other bodies are also do work which get impacted, and hence anybody who has to introduce a feature like this will have to get into various working groups and ensure that their features are taken care across multiple technical specification groups and the working groups within that. And this is just one of them. Over and above this, there were aspects of the broadcasting industry came in, and the narrowband IoT mission-to-mission industry came in, and each of them had to do things, introduced like this. Can we go to the next slide? So the MCX feature, which is a pretty important feature for the railways aspects, with overall over and above the communication aspect, brought in release 11 things like the public safety power. Public safety aspect is not exactly railway. Railway is also public safety. Their needs are slightly different. But then we'll first talk about MCX and then we'll come back to the railways. And they brought in high power UV, they brought in proximity services, group communication, where you start getting you start creating a framework for group communication, then mission critical push to talk feature, which most of the public safety users were already having, and it is not very common for mobile industry. And then you started having the mission critical or data, video, and so on. And going for us from release 15 onwards, they started making sure that it were intervals between LTE and the other systems, brought in broadcast into the mission critical. Next slide, please. Okay, and as we move forward from 15 is where the release 5G got introduced. The aspect of usually you had to get the MCX working even into release 5G, and that is something, and both activity happened in parallel. One is 5G introduction and mission critical feature upgrade, and these are enhanced to the degree where now you can start rolling out interworking workshops started happening from 2018-19 of the MCX players, and they can now, LTE can now be considered into public safety and 3GPP rather than just LTE. 3GPP based communication system involving LTE and 5G can start getting used into the various entities. Okay, so they were earlier using Tetra and other equivalent systems, LMR and DMR and so on. And that is this is an attempt to bring those industry by leveraging the existing. But as we move forward, the expectation is the mission critical, there will not be a standalone network. There will be a percentage of the network which is standalone, but then there will be an overlay between the mission critical aspects of between the mission critical network, the commercial network, and any other private networks laid by people, so that you have, because you can never predict where the disaster will happen, or the police or the authorities, fire authorities have to go in, and they need end-to-end service. Now, can we go to the next slide? This is again like what I talked about as we move forward, but I just wanted to say from release 17, you start putting the railway into it back. Okay, so there is a lot of development that is happening on mission critical, bringing in the data, bringing in group communications, migration, interworking between the current systems and the previous system, between the 3GPP system and the LMR systems, and also the security aspects. You bring in more security, and the proximity services. By and large, what LTE was having is a cellular architecture, and the UHF and systems had a, even though you can technically say they have cell, but D2D works very well in that. How to bring in that and take this to that level is the next sort of challenges that were being brought in. Next. So given this, and as we go forward, these are the feature list expectations. This is at a very high level when we start going into from further from 17, 18 and beyond, all the way till 2030, various releases. This is expectation. In fact, it's not possible to tell what will happen in 2021, but these are all projections. This is just a projection slide that is put here. But now the question is, how do we use this in industry like railways? Can we go to the next slide? Next slide, please. Yeah. So railway communication, I'm using the European rail as the reference, because they are the one who are pushing for the FRMCS. So there was a railway traffic management system which had a train control system, what is called a ETCS, and it was also having the existing GSM technology adapted to meet the railway needs. And a lot of bodies were working together to keep this operational. and bottom gives how the the entities are working together. The diagram at the bottom, how they're all working together and bring this transition. Can we go to the next slide before we come back here? Okay, so GSM-R is quite well heavily used. It is used maybe almost 160,000 kilometers in Europe and close to 250,000 kilometers across. They are talking about migrating it, working towards it, and they brought in what is called a future railway mobile communication system. That is what is called FRMCS. And this transition is managed by a body called International Union of Railways. It is called UIC. And in ETSI, the Technical Committee on Rail Communication is working on this. So what is the need? GSM-R has sort of gone long in the tooth. It does not have any scope for bandwidth enhancements. It is you cannot add new features to it, and the needs of the railway. People are looking at trains more than just transport and travel. They're also looking at it as a place where they also need a lot more communication, the safety requirements, the regulations. Then you start bringing in things like autonomous travels and autonomous train operations, and increase the traffic and so on. That sort of brings in the need to bring in new aspects. So the diagram on the left, if you want to put positioning, if you want to do automatic train operation, if you want to build security, cyber security, and so on, the current GSM-R cannot do. Of course, the companies have sort of committed that they will support equipment till 2028 GSM, all the suppliers. And if you see the diagram at the bottom right, even now there are new deployments which are still happening where GSM-R gets deployed for the first time on that sector. And there are enhancements being done. But over the period of next few years, they will try to see how to migrate that system into a virtual based system, or use the existing hardware, use a new platform, but maintain this as a virtual function and just keep running the GSM-R, and start building up some inventory of the GSM equipment, which will be, as we move forward, there will be a lot of inventory, but hardware stock, but not new products or new deployments or no modernization or upgrades will be done. Okay. Can we go to the next slide? That now brings us to the what we call FRMCS, the Future Railway Mobile Communication System. The diagram on the right shows it is like the blue box is the communication system. What we are talking about is what is the expectation? What do we expect from is that it has to work with the legacy systems, the GSM-R Tetra. It has to work with public networks. It has to work with the ground users and the onboard users. That is everybody from the train, the automated system on the locomotive, the drivers, the staff, the passenger, security, all aspects. And then on the other side, on the ground, you have people on the ground, the normal public, people on the station. You have the track management system, the people, the workers, the security staff, the agencies, and their data servers. So this has to meet the communication need of all these things, including things like IoT and CCTV and things that were not there earlier. It's not that it was never there, but it was not envisaged at the scale now. So the key aspects they built in this FRMCS as a application framework, or a framework of these requirements, and with the architecture which provides what is called a user requirement specification. Currently, it started in 2010. Now it's running in version 5.0. They've brought in functional use cases, how these can all be used, and they've brought in a concept of what is called a telecom onboard system, which has a version 1.0. All this together are fed into 3GPP, and 3GPP has brought in a TR called 22.989, which is a study on future FRMCS. This is currently in stage 1. And since they are starting now and it is yet to get deployed, and it will first version they'll deploy in 2025, the expectation is that they'll straight away go to 5G and it not, even though FRMCS per se does not insist on 5G because it is supposed to be technology neutral. It does not have any technology. It allows for migration of technology. One of the requirements of FRMCS is that the technology migration should be seamless. You should allow for old technology to exist and new technology. So you bring in this what you call the onboard system architecture. There has to be continuity in the signaling, and you also have to transition the spectrum. GSMR has a different spectrum. As you go to 4G, 5G, you will have different spectrum, and then they have to continue to coexist. Can you go to the next slide? So if you see FRMCS, where does FRMCS sit in this whole big picture? So if you look at a train, the one box in the middle is FRMCS, but then because there's customer who has some requirement. The customer is there in the station, he has a communication, there's digital signaling. The train, we are moving towards autonomous driving. Train requires security. The overall campus will have a network which will connecting all this stuff. You are trying to put in things like smart infrastructure, CCTV, IoT based stuff. You will bring in drone based surveillance. Okay. So when you start putting this in, if you see FRMCS is one aspect of the overall communication requirement that is being brought in there. Okay. Just for a perspective, what is FRMCS? What are the other things? Where does drone come in and where does IoT come in and so on? Okay. Next. So this is the expectation, that is they will try to move this. They will try to the UIC will push it into the HC first. They all get together, work. There's a body there. Then they start pushing the stand. Rebuild functional requirements. Make sure it is having bearer independence, and then start upgrading away from the GSMR. Next slide. And the diagram in the left, if you see the top portion, there is a user requirement that is brought by UIC. Then they bring in the use cases. From there, the technical reports, which then a task force in UIC will push it into 3GPP. So this is the relationship between what FRMCS and HC does and how it relates with 3GPP. And then at various releases, they've already started incorporating. This is already started from 15-16 onwards, voice, data, video, multi-talker, and so on. And some of them, they will leverage the existing MCX sort of features, but over and above, they are bringing in a lot of other aspects which are specific to the train. And if you go down the list, the green, the dark blue, and so on, the ETCS communication, automatic trains, and bearer flexibility, interworking with GSMR, and so on. Okay. And the diagram on the right sort of shows if the bottommost platform, the bottommost thing is the 3GPP. Then as we move up, we have normative technical specs, which is from there you build up. There are a lot of building blocks which is used here, which some portion of them gets used by the FRS and SRS of the rail specific things, and which is then used as an application specific to the trains. That is, 3GPP becomes like the master building block specification suite, or the TR suite, with which out of the subset is pulled out by HC through UIC into the application. Okay. It is not like 3GPP is completely changed for railways or vice versa. They are trying to ensure that they use the 3GPP framework as the foundation and over and above build this. Next slide, please. Okay. So there's a mechanism. How does the document? So if somebody has a standardization person, if you want to bring in something into 3GPP, what is the correlation between UIC, HC, and 3GPP? So you make these documents, you build this function, you user requirement function, use cases, get it discussed in HC, then the task force goes into 3GPP SA1 and TR 22.889. This is a slightly older diagram, but it was a very nice depiction, so I've used this so that people understand the ping pong between UIC, HC, and 3GPP, and with respect to the specific documents. Because in the end, your needs and desires have to go in the form of documents, work items, study items into 3GPP and back. Next slide, please. So if you see what is FRMCS, there's a railway communication system which is sitting over the FRMCS transport services, and you use the railway application and services. They have built in some critical system principles. That is, it need to support critical applications. It has to have a specific amount of performance. It must support the business applications. And as we move up this one, it starts getting more and more integrated. And the FRMCS also does 3GPP radio access, non-3GPP, and so on. But it should allow for interworking with the existing GSM market. Next slide. So it's a more detailed diagram of the same. And if you see, it allows for the FRMCS application, railway application, to talk from one application to another using the core radio access network in the middle, UE. But it also allows for non-MCX enabled other applications. Okay. And because it's just indicative, I'm just trying to state these things are there. Because of lack of time, I'll not talk too much about this. Next slide. There's a more detailed diagram here. Next slide. Okay. Which talks about how the interworking between GSM on the left side and the 3GPP happens, how the 3GPP RAN and the non-3GPP RANs can interwork, and how the various railway applications in the bottom tier can be hooked up to the railway services, okay, on the top using the core RAN and UE in the middle. Okay. It also allows for fixed network interworking with the other applications. Okay. So this is the higher level architecture that FRMCS provides. Next slide. Okay. This is an onboard architecture. They had to freeze this and make sure that this is formalized so that you will have to do transition between the existing technology and the newer technology. Next. Okay. Question of spectrum for the FRMCS is talking about 800, 900, 1900 existing GSM and around that bands. There was also a discussion on 2300, but in India, its railways is going to be using 700 megahertz. It's already been allocated and they've already started trials and POCs. Next slide. Okay. So overall plan, they will do version 1. They have started doing some sort of testing and trials. They'll freeze the specs, and then approximately on 2025, they will do it in 3 stages: a stable version of specs, build a POC, and then do a larger trial. Okay. Next. Okay. This is something migration aspect. I'll skip this. I've already talked about in the previous slides. Next slide. So this is the expectation. What does the railway industry think about how the FRMCS will go through? Okay, phase 1, there will be some sort of demos and POC. The functionality is limited, but it will be mostly 3GPP and MCX, MCPTT. And as we move to phase 2, they will bring in a small amount of, this is what we call the European level trial customer POC. 25 to 28, they will start doing commercial initial pilots and start bringing in the functionalities, okay, of critical voice, ETCS, train operations, broadband, and so on. And they are expecting large deployments to start somewhere around 2028. Okay. It can be even earlier, but this is the current expectation from the industry body called UNIFE. Okay. Next. They also listed a lot of success factors. In this discussion, I have not talked. They will also talk about how does satellite and railway communications work, how does road ITS, V2X, and railways interwork. That is something that has to come in. Next slide. India, the RDSO and Indian Railways, they have already come out with a technical advisory note. They have another system called Train Collision Avoidance System, TCAS. They have a signaling system, the Kavach. All these they are trying to evaluate, interwork with a POC. The relationship between this and I'll leave it out of the talk for today because my focus is more trying to just landscape. Next slide. So the current work item, the study on FRMCs, I just laid the groundwork. I sort of used a lot of diagrams and slides to put up. So the 3GPP, the ID, TSG, there's a document called 95007, what is called a study on FRMCS phase 5. And this maps, the use cases are mapped to TR 22.989 and supposed to do gap analysis between FRMCS and the 22.989. It tries to identify new use cases and see the requirements, what can be pushed into. Output is an enhanced version of 22.989. The right side gives the current list of use cases and bottom gives the preceding documents that are put together. So members here in India, whatever, can look at this framework and see how is it that we can discuss, put together and join this. Okay. So we are also having train communications. We are having the framework here. And given this 3GPP, UIC, and E8C, and the Indian network, what is it that we can work? These I leave it as an open question. This is just a landscape presentation on what is happening there, what is happening here, how we can get in. But this is the work item through which FRMCS and the railway communication system, future railway communication, can get in. Next slide. Okay. So there's another study called Study on Railway Smart Station. Now it is not exactly FRMCS, but then we are talking about how, in case there is a fire in the station, what can be done, what are all the process procedures, how to use a CCTV, how to use a communication system, how do you use a UVs and so on. To increase the throughput in the railway station, how can we do multiple trains in the same platform? Or how do you guide the passengers towards that? How do you manage the timing and so on? Okay. And what can be done for the convenience of the customers? And a lot of some of the countries have started having safety, to prevent accidents of the passengers falling onto this one, saying platform screen doors. They have doors to the train which open only when the train comes in. Otherwise, it's just like a closed wall. And the timing of that, can it all be automated and can it all use the integrated system? And railway station is a security area where a lot of people coming, people, material, and so on. How can we merge these, or not merge, but how do we get all these to interwork? And how do we enable automatic monitoring? Because it is not possible as the usage and the number of people start increasing and mobility increases. Okay. And how can we manage the kiosks? How can we manage the mobility services? If somebody is disabled, can we provide assisted service? Okay. These are some of the aspects. This is also another place where the Indian railway station, we can, when we work towards smarts, what are our needs, we can also work towards making it, evolving standards and promoting it at a international level, or benchmark both these, either benchmark from there to here or ensure our needs are taken care there. So these are the two aspects that are, which I picked up, but I spent some time giving the background of how 3GPP comes in and how do you get a feature into the system and how it takes many releases for the features to get together. And then somehow we'll have to map that into a specific work item, study item, and phase into the releases. Okay. Next slide. I think that's about it. This is just the list of references that I've picked up. Some of them, in case there's any source that is missed, people can just get through. There's a good amount of information available in public domain. Okay. Thank you. Thanks to TSDSI and DoT for the opportunity.
Thank you, Prakash. Thank you for thank you, Prakash. Thank you for the excellent insight about future railways topic. And I think you've given very exciting messages for the Indian community in here with all the innovations in the railway space that is possible. And I'm hopeful that people will join the efforts in TSDSI and in 3GPP to take it forward. Thank you so much for these excellent insights. Now we go to the last part of the technical topics and the most exciting one as well, which is on metaverse. And our speaker for the topic is Mr. Eric Gutman. He's a staff engineer at Samsung Electronics R&D Institute, UK. And he has an extensive experience in network and communication standards and has served in the capacity of chair position in IETF, 3GPP SA2, 3GPP SA plenary, to name a few. So, and Eric has led advanced development projects to introduce functionalities to support emerging standards in products, very notably the Solaris operating system while he was employed with Sun Microsystems. He also participates in research in diverse areas of networking and has several publications and patents to his credit. And Eric is currently the rapporteur for the feasibility study on localized mobile metaverse services in 3GPP SA1 working group. And it is our privilege to have Eric provide us the insights into this study. So please join me in inviting Eric to deliver his presentation. Eric, over to you, please.
Thank you for a kind introduction. Please proceed. So I'll talk a little bit about the context. You've seen other slides like this, but this is maybe a little bit more focused on how the release 19 studies are going to be realized in the next release and when and so on. Please, next slide. So SA1 provides requirements to the other organizations in 3GPP, most particularly to these stage 2 groups. I would say it would be a little bit exaggerated to say that all of the work in 3GPP requires SA1 requirements. They all require stage 1 requirements, but not all of them come from SA1. So for example, in SA4, they do a lot of stage 1 work. SA5 does almost all its own stage 1 work. Where stage 1 work is most important from SA1 is for SA2 and SA6, which go on to do new system features. There are also quite a lot of requirements that go from SA1 to CT1, which does the terminal standards, but also the end-to-end standards. So for example, mission critical communication goes directly from the terminal to the server, and that's all defined in CT1 as well. So that's kind of the role that SA1 plays in the organization. Let's move to the next slide, please. So here you see the specifics of the kind of project for this metaverse study. And we've been studying it for some time, and by the time we get to June, we need to complete the study and work on our normative specification, which are CRs that consist of really, they're just the requirements. Maybe a little bit of text to describe the service. So when you read the system's requirement specification 22261 and other requirements, you have a sense of why the requirement was put there and what it means. The requirements are very spare. This sort of describes how there will be a workshop in the middle of the year, and we're trying to wrap up our study so that at least in terms of the indication of where the standard is going to go, that could be considered in the release 19 workshop. And by the end of the year, we have to conclude all of our normative work so that it will be relevant to the actual prioritization of stage 2 studies that will occur. We can see that looking sort of beyond the horizon of 2023, that the stage 2 work will start, and somewhere in 2025 it will conclude the entire release 19 feature. And then somehow in early 2024, which is not that far away now, less than a year, SA1 will begin work on release 20. And this could be the first study for the 6G system, and what are the services that it will require. So I'll talk a little bit more about that at the end of my presentation. Let's move on to the next slide. So I'm going to talk about the metaverse study here. Next slide, please. The metaverse is a very broad term. I mean, honestly, it means nothing. It comes from a science fiction novel from the early 90s, where the character kind of would go into this virtual world and do things and come back, and the stuff that he did in the virtual world mattered, the stuff he did in the real world mattered to the virtual world, and it was all just kind of, I don't know, interesting, inspiring. So here we are, 30 years later, and we're still using the word in a vague way. It sort of means that you involve AR and VR applications, but honestly, the term metaverse, I'm actually working right now cleaning out the whole technical report for every time somebody says the word metaverse as if it means something. So what we try to make it mean in our study is that we're going to use XR media, which is a combination of AR and VR, but also all kinds of other media, traditional video and haptics, and in a coordinated interactive way. That at least is true. Also, we want to find out how these services, which are being developed in all kinds of ways now, both over telecommunications networks and just over with devices, how can the telecommunication system help? What can the telecommunication system do? That's sort of the role of 3GPP in all these verticals, and in particular here. Now, for our study, we emphasize what's locally relevant, persistent, shared content, not just for one person, but for others. And either they're in the same proximity as where the content is local, or they're remote to it, but they somehow can see it and interact with it. The reason why we're focusing on this instead of just sort of VR, whatever, because honestly, VR has been studied in 3GPP for a very long time. Media delivered over the 3GPP network is kind of old news. We've been doing that for over 20 years. So what is specific and interesting about this? So here, there's some challenges to make the information timely. So if it's AR and things are moving in the world, the AR should correspond with it. If there's an information blob on top of something, it should move with the thing that the blob is on. So how do we do that? How do we synchronize that? How do we make sure the availability is good enough that the service experience is okay? So please move to the next slide. I just want to make clear that we're not surveying all the work that's going on in other SDOs, what's happening in open specifications, what's happening in the market. We're just not talking about that at all. We're talking to some extent about the current research and opportunities. So maybe there are people who have looked at, a survey of the field of remote telemedicine and how these sort of media applications can help. Specifically, we're trying to find use cases where the mobile telecommunication system can make a difference, where it's not just these platforms that are providing all kinds of interesting innovation and service opportunities, but the 3GPP system itself can play a role. And so we're always, 3GPP is this partnership project with these different OPs, and each of these OPs is, you get a sense from the discussions today, there are all kinds of stakeholders, and they're trying to figure out how to do the best for, are they a vendor, are they an operator, are they a regulator, are they, from a particular business sector. Here, these metaverse services are so vague that they'll apply to all sectors in some way, right? If you're talking about agriculture, it could be useful for somebody who's managing the agricultural installation to visualize, where am I getting proper irrigation and where not, and where do I have a concentration of pests, or is the heat improperly distributed? All these kinds of things you can use, and that's true in the industrial sector and automotive sector, all these. So here, this is kind of like a meta level service. Anyway, let's move on to the next slide. Okay, so the study itself, this is the scope. So in 3GPP terms, we kind of have a contract when we start work, and the scope says, like, what are we going to do? And if you try to do something that's really far outside of that, then people say, no, come on. So in the beginning, we focused on this, and so here we want to investigate use cases and service requirements to support these enhanced XR services. And we want to offer shared interactive user experience of local content and services accessed by users in proximity or remotely. Shared is a really important point because it's kind of easy to provide a user experience for just one user, but if you want all sorts of users to have a mutual experience, that's tricky because you have different modes of communication and these all have to be synchronized, not just for one person, but for all these people. And that's why we're talking about the performance aspects, efficiency, scalability, how to use different kinds of media together all at once. Some people some of the participants are interested in identification of the users and of the objects and digital representations and like digital things in the metaverse and how they could be managed or the use of them could be facilitated by the 5G system. And I think that all of these approaches together, with the exception of the few that are suggesting new services for 3GPP, have a common sort of point of reference that we're looking at a way to provide a mediation between these platforms and metaverse services and the user, because if there are many different services and platforms, how do they become integrated for a single user experience? So that you don't have to kind of turn off the interior decoration of your house when you take an AR call. I'm assuming that you have like AR wallpaper and decorations in your house or something like that. Okay, so now another aspect of all this is how do we get sufficient information uplink to these platforms so that they can perform the rendering and the whole interaction between the user and the service when we need to know the user's facial geometry, we need to know their gestures, we need to know their pose, we need to know what is in their environment. All of this you can kind of summarize in the term localization. So how do we expose this information and what can the 5G system do to support that? This is an overview of what we're trying to do, and I'll now explain what we've done because we're kind of at the end of the study process. Let's move on. Okay, so there are kind of three new services that people have described. One is multimodal XR conferencing, which means that maybe it's a 3D conference and you're all seeing the same thing and interacting with it in a kind of compelling way, whether you're in the same location or you're somewhere else. I'll show you that. All three of these I'll explain a bit. And then avatar call is like a new way of having a call where you're not looking at a video image, but an avatar image. I'll explain why that's interesting. And localized mobile metaverse services, which is a way of facilitating experiences that are in the real world, but have metaverse elements. And then there's a whole list of enablers to do that people have described it. And I encourage you to look at the technical report for more detail. If there are any questions, maybe I can come back to this. Let's move on to the next slide, please. So the first use case I'm going to talk about is the localized mobile metaverse services. So this is kind of like, at least for me, you know, I contributed this. This is the kind of motivation for the whole study. So there used to be this wonderful piece of service architecture defined by NTT Docomo in the early 2000s. It was called iMode. And with your iMode device, which is like a little text-based display, tiny little postage stamp sized text display, you could move around in the world and receive information that was specifically pertained to that place. And you could configure it saying, I'm only interested in this or that or the other thing, and you get it, and there'd be channels where you get relevant information that might tell you how to drive or where to eat or what to buy or whatever. And that all kinds of merchants could provide their content so that as you walked into their restaurant, it would tell you, information you need to know in that restaurant. You could buy something right there on your phone. So like this thing was like way ahead of its time. So how can we do that with AR? That's the question. And so there's a kind of a concept figure here. We're walking through a train station and we're like, oh, on the right-hand side, I have that on my shopping list and it's cheap here. Maybe I should go into that store and buy it. Oh, I'm kind of hungry. I normally eat around this time. There's some soup here and I had some and I liked it. Maybe I should stop there and get some soup. This is the kind of thing you could do. Now, how could you do it? Well, we have this notion of spatial anchors, which you could stick in space, and you would actually be able to identify that the user is in this location, that there is this anchor, that the anchor has service information, and the service information pertains to what we're interested in. So we launch the service and show the media, which is shown in these little AR blowouts. That's the concept here, and we have a number of requirements associated with it. That's one of the services. Let's move on to the next slide, please. So another concept is the AR, is a 3D avatar call. Now, obviously, we have had the video call since the early 2000s. Like, who cares? Like, we have this framework called IMS that can provide you with the ability to start calls and terminate calls and all kinds of fancy things for call sessions, and that's all there. What we can do with that is move any media at all, and the media that we typically move for a call is audio and video. Well, it turns out there are all kinds of emerging standards now for defining codecs for avatars. Now, the reason why this is kind of interesting is that instead of requiring a megabit or several megabits a second for a video call, this needs kilobits. So this is like really small communication that can work in in communication constrained environments. Furthermore, it actually looks like the person. It's a nice 3D representation of the person, and sometimes you want a nice representation. I mean, you might be Adonis here, completely greasy from working in the, in your garage, and you might be Aphrodite, who's completely exhausted, and you want to look your best for your. Okay, I don't know if it's kind of contrived, but here we have it, right? It might also be that you're speaking to a piece of software, and the software can render itself as a person and actually interact. So there are different cases and so on where this could be valuable, and there are various use cases in the TR that also go in this direction. Let's move to the next slide, please. So the third example of 3 that I'm going to give is how to have this sort of immersive AR experience. And so you see in these figures that there are people who are present and interacting with the 3D representation that's in that environment. And then there are remote participants. And those remote participants are able to see the same people and interact with that themselves in the same way as a first class participant. Now, the 2 use cases that we have in the TR which express this are collaborative engineering, which you see in the upper left, and telemedicine on the lower left. These are very demanding use cases, as you can see. Now, there are various requirements that kind of hide behind this. How do you know who can get this information? Who can participate? How do you have high performance enough communication so that these interactions are compelling? It's particularly important to consider how it remains in focus for the people that are present. I want to emphasize that there's a lot of experience we now have with gaming, where there are distributed games all around the world, huge latencies just because of the speed of light, and yet people can participate in the same game with whether it's 2D gaming or 3D gaming, it doesn't matter. Now, how does that work? If there may be 200 milliseconds of latency just for the communication minimum, and yet they're fighting each other, or they're fighting monsters, and they all agree at the end, that was really realistic or exciting or whatever. The reason is that if you aren't in the same place, then and you only have one piece of software that's defining all of the actions, that piece of software can create an ordering, and that ordering is not the same for everyone. So somebody sitting in China, somebody sitting in Hawaii, somebody sitting, you know, in Delhi, they may think they're seeing something that's happening simultaneously, but it's not. It's very easy for the media to be sent to these different parties, and they feel that there's causal ordering, but it's just a simulation. However, if you are actually in the same place, like the doctor and the patient, or the two collaborating engineers here in the upper left, you can see, you know, one person touches something, and then, you know, 3 seconds later, something moves for you, or even 30 milliseconds. It's not acceptable. So this is very tricky stuff. Another aspect of all of this that is interesting is this VR experience, as in these games. So if I am using these different applications, perhaps, and services, I would want to have the same avatar in each case, or I would want to be able to have some digital asset that I could use in each of these cases. There is some, I would say, precedent for this. There's a whole EU initiative, something called a digital wallet, where I can collect all kinds of bureaucratic information together in a virtual way that is associated with my identity. And so I present my identity maybe on a card or with my phone, and all of a sudden a doctor in one country is able to use my medical records for another country. Now that may seem like a small thing, but it basically, even within one government, there are agencies that don't know anything about the other agencies. And if you could sort of pull all that information together, and you as a user would grant access to it, all of a sudden you could just smooth over a whole lot of bureaucracy. It would be much easier to do business. It would be much easier to move around. It would be much easier to get medical treatment. One doctor could see the records from another doctor, and all this kind of stuff. So this is all, I mean, looking really far beyond just, you know, multimedia experiences. I think this is kind of exciting. Let's move on. Next slide, please. So I want to talk about the status and next steps of this project, and I would say the whole release 19. So you've seen these kind of project management diagrams before. This is a slightly different take. You can see release 18 is still concluding. So 3GPP is this kind of strange beast where we're concluding, we're starting, and we're moving ahead all at the same time. So release 18, I would say most of 3GPP is absolutely busy with this. And release 19 is a sort of just a smoke, and we're trying to put a few pieces on the ground. And so SA1 is the furthest along, but you can see we're only going to finish our work to the point where you can say concretely, this is what SA1 has done in December. And then you can kind of project, and that's why it's kind of fuzzy and gray. You can project that it's going to, that work is going to extend really pretty much into 2026 based on the current pace of work. Maybe it'll finish by the end of 2025. And then we have release 20, and that's, I mean, no one's thinking about release 20, but it's clear that it's coming early 2024. We're gonna start that in SA1 because we'll be finished with release 19. Now, all of this is kind of looking forward to this 6G first release. Why in 2030? Well, because that's what the ITU likes to do. They do every 10 years there's a new generation. So we can kind of see that this release 20 is aiming that direction. Are we going to have another 2 releases between then, or 3, or 1? I don't know. Nobody knows. But this discussion is either going to be on pre-6G or on 6G itself that starts in 2024. And that's kind of exciting. Next slide, please. So how does the metaverse study fit into this kind of future view? Well, we're going to complete some of the requirement definitions that we described, and there are going to be projects started in SA2, SA4, and SA6. And obviously, which proposal and which requirements, that depends on the individual members. So Samsung will propose some, and other companies will propose other things, and hopefully we'll all agree on a few of them, and those will be done. I also point out that this metaverse topic is extremely large, and we're only touching the surface of it, so we may continue it in release 20. Some of the topics that we probably won't even do in 5G, but are more oriented towards 6G. So this is kind of like a pre-6G topic. Digital twins, where you can actually perform an action on this virtual representation or this model, and it'll have an effect on the real world. So, for example, having actuators. We haven't even talked about actuators in 3GPP. Super high degree of synchronization, low latency for large numbers of people. So everybody in a stadium can have the same experience. These are things that I expect will be part of 6G. And I'm finishing on time. Thank you. Next slide, please. Yeah.
Thank you, Eric. Thank you. Excellent. You managed the time well, as well as you took us through the stories. I mean, it's a great talk, which where you shedded the light on metaverse topic with the use cases, providing some very interesting stories. And I'm sure this has ignited the imaginations of the audience. So we are very excited with, as I said, we just scratched the surface, and everything is left to imaginations of what is going to come on this topic on 6G. So thank you very much for your very exciting talk, and we had the privilege of having you speak as in your time zone, and thank you for making this effort. Now I think to the audience, thank you so much, Eric. Now to the audience, please keep posting your questions, and we are working very hard at the back end to see that your questions are answered as you're raising them. And now we will quickly go on to the poll. So these polls are designed to gather your interest, and especially on the topics that we have discussed today, especially on the interest in 3GPP, getting more information about 3GPP, getting more information about the work that 3GPP is doing with respect to the technical topics that we just shared on verticals, vertical application and services. And we hope to use this information to further engage with you in a more organic fashion, and work towards looking at your innovations and imaginations and requirements that are coming from your Indian scenarios that can be compelling in a way that can be submitted within 3GPP going forward by the procedures that we follow. So we will quickly take you through poll. There are 4 questions that we would put up, and I will introduce you to the questions, as well as there will be time allocated for each poll. I think around 15 seconds, I think should be good enough. And soon after the poll completes, there will be a poll result that will be displayed. And I hope you would be all able to provide your, you would choose the options on the poll as we go. Can we go to the first poll, please? Yeah, the first poll is about how familiar are you with the 3GPP standardization process and release timelines. So please select one of these options: very familiar, somewhat familiar, not familiar. And your time starts now. So we'll give you 15 seconds to please provide your choice. Okay, thank you. Can we display the result, please? Okay, sounds good. So very familiar, 29%, somewhat familiar, 61%, not familiar, 10%. Thank you for providing your viewpoints here. Can we go to the next poll question, please? Yeah. So this is about, do you agree that a dedicated workshop about the 3GPP process is required? So please select one of these options. One of the, you strongly agree, cannot contribute without that. The other option is partially agree, it can be useful, but I can still manage. The third one is don't agree, not really required. Yes, time starts now. Please make a choice. 15 seconds. Thank you. Can we have the poll result? Oh, that's excellent. So there's a very strong need to have the dedicated workshop. 75% of them strongly agree, 23% partially agree. Okay, can we go to the next poll question, please? Yeah, so this is the poll question about the technical topics that we had today. So which of the following does your organization have a strong business or research interest? So this is a multiple choice question, so please choose all that applies. So the options are as below: metaverse services, M2M IoT services, UAV or drone services, railway devices system and smart station services, and or none of the above. So please choose the appropriate one. 15 seconds starts now. Excellent. Can we have the poll result, please? Okay, excellent. So metaverse 45%, IoT 85%, drones 79%, railways 38%. So all topics of 3GPP studies are of immense interest to the audience. It's great to know this. Can we go to the next poll question, please? Okay, and apart from your interest, we would also like to know which of the following topics is your organization interested in contributing to 3GPP. So this is very, very much relevant to 3GPP itself. So please choose all that applies. It's a multiple choice poll. So again, the topics are the same. So localized mobile meta services, ambient power enabled IoT, UAV phase 3, FRMCS phase 5, and railway smart station services, none of the above. So please choose all the topics that your organization is interested in contributing directly to 3GPP, and TSDS as a platform to do that. Your 15 seconds starts now. Thank you. Can we have the poll result, please? Okay, that's excellent. So we have a lot of interest in all the topics to be contributed in 3GPP. So I think these poll results and the information that we have will be used to connect with you, to engage with you further in all these topics, not only from this workshop, but we also have similar poll results from the previous workshops. So our team from TSDSI will be reaching out to you and getting to understand more about your interest, and we will connect you with the TSDSI platform of how to take your interest forward. So thank you for participating in this poll. We are already around 12 to 15 minutes, I must say 20 minutes delayed, not just 12 to 15 minutes, but 20 minutes delayed. And I've seen a lot of questions that have been coming up, and our team has been working the back end to answer all your questions. So I would want to kind of probably skip through the Q&A online, and we would still encourage you to send out emails. These presentations can be made available, as well as the video will be posted on YouTube. So you could please connect with the speakers directly, or connect to TSDSI Secretariat and post your questions, and all the speakers will be very happy to answer your questions. So now we go into the last segment of our workshop, which is the concluding remarks and next steps. And I invite Samar Shailendra, the co-chair of the TSDSI Roadmap Committee, to please grace this occasion by providing concluding remarks and provide insights on the next steps. Thank you. Floor is yours, Samar.
Thank you, Nirant. Thank you very much for again giving me this opportunity, and I'm really honored to provide the closing remarks for the first micro workshop series, which we have undertaken as part of the DoT and TSDSI collaboration together. I also want to thank incredibly all the speakers today and also the speakers who were there also in the previous workshops. Eric has been phenomenal. I mean, metaverse is a great topic always to hear about. Niran spoke about ambient power-enabled IoT, the need of the hour, and I saw there are a couple of questions on this as well. So I encourage everyone to connect with TSDSI, 3GPP, and Niran about it. Pallab spoke about the drones, again a very interesting topic and very sought out topic in India. DGCA has been very instrumental on it in creating all the drones related requirements, specifications, etc. And 3GPP is heavily investing a lot in the drone specifications. And lastly, to Prakash, who spoke about the FRMCS and the smart railway station, and I think that's closest to India. The model has been also driven by European organizations, and most interestingly, the interaction between the UIC, the DoT-TSDSI, and the 3GPP is the model which we are also trying to replicate in India, where the organizations like yourselves, the TSDSI and the 3GP plays the pivot role in creating all these specifications around it. So this has been an incredible journey. All the first series of micro workshops, we are very thrilled by the overwhelming response we received. More than 500 plus participants participated in the first series. Special thanks to everyone who could find out the time for this, filled out the expression of interest forms, because that's very crucial for the workshops, and it encourages us to make the things and execute such events going forward. All the talks which we had today and the earlier, these are the game-changing areas of research and standardization for the Indian ecosystem. If you're working in these areas, please do connect with us. TSDSI is there to promote and turn your work into standards. And that's the primary reason TSDSI has been formed by Government of India. As part of this workshop, we wanted to raise awareness, which I believe we are partly successful, if not completely, and we'll continue doing all such workshops to increase the span, to give more insights, to give more working. And as Eric mentioned, release 19 is just the start, release 20 is around the corner. So I believe for some who are experienced with the 3GPP system or partly experienced, the time for them is to gear up and release 19. For the rest of the people who feel that they are not still well versed, release 20 is the place to go. And all of that, TSDSI is providing a platform and an opportunity to use it, collaborate, and participate. We'll continue with all these workshops. The next workshop is planned on the 17th of February. Now we will deep dive more into the technical topics, more closer to this. Till now we have seen a overview of all this work. Now we'll go into the specifics and deep dives and the forward-looking work which is happening. So the next workshop, in the next series of the workshop is planned, and the first one is targeted on 17th of February, which will be focused on the physical layer technologies. TSDSI will be reaching out to you with more information and details. So please watch out for this space and communications from TSDSI. Again, I want to thank you all from the organizers, TSDSI Marcom, Secretariat IT team, and most importantly, all of you, without whom this event would not have been possible even. We'll also reach out with you. You can participate in the TSDSI roadmap committee as well if you really want to know more about all this stuff, if you want to contribute more. So remain engaged, keep participating, reach out to us, send out all your queries, anything which you have in mind, please write it back to us, shoot out to us, and we are always there to help you with. So let's keep the momentum going for all these workshops also. We will see you again on 17th February. Looking forward to great enthusiasm and participations from all of you. So with that, thank you very much. I'll hand it over back to Nirant, and hoping to see you all again.
Thank you, Samar. Thank you for the concluding remarks and also exciting our audience to connect with us more. A very big thank you to all the audience members and the speakers, and the organizing committee. Not really, I mean, I don't want to name one person. Everybody have contributed to the success of this particular workshop. Thank you very much. And with this, we would like to engage with you further, and we'll call this workshop a close. Thank you very much. Bye-bye.
Thank you, Nenan. Thank you, everyone.
Thank you. Bye.
Thank you.
Thank you, bro. I'm just ending the session.